Hi everyone, my name is Gibbs. Today I'm here to show you how to collect like terms in algebra. Now, if you want to know more about the algebra, I explained that in my other video, which is the introduction to algebra. So you know what the algebra is talking about. Here today in my video, I'm only here to show you on how you can collect like terms in those algebraic expressions. So now, let's give one example so that you know what we're talking about. Now, assuming we have this, now this kind of expression here, this kind of equation is known as an algebraic expression. I will be teaching you on how we can be able to collect like terms, and then after collecting like terms, we'll solve for this, we'll get our answer. So I will show you how. Now, since we are seeing a coefficient here, and then also we are seeing also a coefficient here, I said when a number is attached to a letter, is called the coefficient. That means it's the coefficient of that letter there now. That means the coefficient of y here now is what? Is 3. The coefficient of y here also is what? Is 5. I did more of the explanation in my introduction to algebraic expression. So if you want to learn more of this, if you want to know all these things, you need to get to my algebraic expression, which I did the introduction. So with that, you will know what is the coefficient, what is the constant, and the variable. I differentiate that. So now we have the coefficient here, we have the coefficient, and we have constant here. So what we need to do is that if we want to collect like terms, now if they are giving us something like this, normally we are supposed to collect like terms. If we want to collect like terms now with this now, those ones with the coefficient, those coefficient will bring it one side, and then the constant will bring it the other side. Now, what is separating these two things is what is the equal to sign. Now, we notice that this equal to sign is separating the coefficient from the what? From the constant. So, if we want to solve this now, we'll first of all separate the coefficient and then also the constant. Now, I will show you what I mean. We have 3y here minus 5y. So this one is already arranged for us. So put our 3y minus 5y. Now, after putting 3y minus 5y, now we are seeing plus sign here, plus 2. We are not going to put plus 2 here because this 2 here, this positive 2 here, is not a coefficient. It does not have what? It's not having what this y here attached to it. So we are not going to put plus 2 here again. No, because this one now is constant and then this is constant. So we'll separate them. We'll separate the constant from the coefficient. Now, in order for us to do this now, instead of now to put this plus 2, we are not putting plus 2 because plus 2 here is a constant. So what we are going to do, we'll put what this equal to sign for us to separate it. So bring your equal to sign. And then after this equal to sign, what are you seeing next here is 10. So you bring down your 10. And then this 2 here is having what? Plus 2. This is positive 2. Not just 2, but plus 2. So when this plus 2 now is crossing to this side, because this plus 2 will go and make this 10. Because they are constant. So plus 2 will go and make this 10. Will now change to minus 2. So that is how to collect like terms. Now, you have succeeded in collecting like terms, and then all this thing is what is arranged. You are seeing that the coefficient will have it one side, and the constant also will have it the other side, and then this equal to sign is the one that is separating the coefficient from the constant. So you have seen that. Now, having done that, now we move to the solving. Now, if we have 3y minus 5y, now I told you that this minus 5 here is the one you are owing, and then this 3 here is the one you have. So if you pay off, because you must surely pay off, if you pay off this 3 that you are owing now, how much is remaining for you? That means you are still owing what? 2 naira. That means it's minus 2. Because of you are still owing 2 naira, that's why it's what? It's minus 2. So we have minus 2y equal to. Now, 10 minus 2 give us 8. So we'll put our 8 here. So now, having done something like this now, what are we looking for here? We are looking for this y here. Now, because we are looking for y here now, we'll divide both sides by the coefficient of y, by the one y is having, which is -2. The coefficient of y here is what? Is -2. So we'll divide both sides by what? But by -2. So let's do it. Let's divide both sides by -2. Divide also 8 by -2. So now, so that -2 here, I can cancel this -2. We are left with just y. So our answer is what? Y equal to 8 divided by -2. This will give us 4. But we are not going to put just only 4 because we are seeing a minus sign here. So it's -4. So we are putting what? -4. This is our answer. Now let me give you more of the examples so that you will know what I'm talking about. Now look at the second example here. We are having 29 equal to 5a plus 14. You are supposed to collect like terms. Now I told you that if we are collecting like terms, we'll make sure that the constant is different from what? From the coefficient. Now we have only one coefficient here now, if you can see. We have only one coefficient here, and then we have just two constants here now. So we make sure that this constant is different, is separated from the what? From the coefficient. Now what are we going to do? Now because of this 29 here is the one coming first, so we'll put what? Our 29. Okay, collect like terms. Like terms. Now, you bring down your 29 since it's just a number that is coming first. So we'll start with the numbers. Let's bring down our 29. And then we still have other constants, is it not? Which is plus 14 here. So this plus 14 now, remember we have an equal to sign now. So this plus 14 now, it will cross over to this equal to sign to go and meet this one. When it's crossing over like this to go and meet this one, it will change to what? Minus 14. So here now will be what? -14. Now we are done with the constant. There is no other constant here again. It's only the coefficient that is remaining. So equal to the 5a. So having done this now, what we need to do is that we just minus 29 from what? From 14. So now let's solve it. 29 minus 14 will give us what? Will give us 15. So that's it. 29 minus 14 will give us 15. So we have 15 equal to 5a. Now what are we looking for here now? We are looking for what? The variable, which is just a. We are not looking for coefficients. We are looking for always the letter, which is the variable. We'll divide both sides by the what? By the coefficient of a. Like I said, this is the coefficient. So we divide both sides by this coefficient of a, which is 5. The one a is carrying here now is what? Is 5. So we divide both sides by 5. Divide both sides by 5. Divide both sides by 5. So that this a can be left alone. Now 5 will cancel 5 here now. We are left with a. Normally, a is supposed to flip this way. A is supposed to be at the left hand side and then equal to a number. So we will now get a equal to. Now we have this 15 now. 15 divided by 5 will give us what? Will give us 3. So that is our answer. As simple as that. Look at example 3 here. Example 3, they said we should collect these like terms. Now we have 5x minus 8 equal to 52 minus 7x. Now, if you have such a thing like this now, such an algebraic expression like this, or an equation, what will come into your mind is that you do what? You collect like terms, because we are having coefficients and coefficients here, and also we are having constants and constants here. So like I said, we will try to separate the constant from the coefficient so I can be able to solve for it. That's how to collect the like terms. So first of all, what is coming here first is what? Is the 5x. So let's put 5x. Collect like terms. Now, let's put our 5x. Now, we are having minus 8 here. Minus 8 here is not a coefficient. It's not having any s attached to it. So, we are not using minus 8. Leave minus 8. Now, look at the one that is having x attached to it, which is 7 minus 7. So, this is a coefficient. So, now we are having minus 7 here now. Remember, minus 7 now will now cross to an equal to sign because there is equal to sign here. So this minus 7x will cross and go and meet this minus 5. Go and meet what this 5x. So if minus 7x is crossing over to go and meet minus 5x, it will change to what? It will change to what? Just plus 7x. So we have plus 7x. Now, like I told you before that if a number is crossing over and if the number is what is negative, if the thing is crossing over to an equal to sign, it will change to what? It will change to positive. If it's positive, if the thing is crossing over to an equal to sign, it will change to what? Negative. I already explained that in my algebraic expression video, the introduction to it. So now, let's continue. Now, after this now, do we have any other coefficient here? No, we don't have any other coefficient. So what we need to do is that we put our equal to sign. And then after the equal to sign, what are we seeing here? 52. So the green line of 52. And then this is minus 8 because this one also is a constant. This minus 8 is a constant. So this minus 8 now, go and meet this one, will now cross over. If this minus 8 now is crossing over, it will get to what? Plus 8. So we are done with collecting of like terms. You see that collecting of like terms is something that is very simple, it's not hard. So now let's continue. Now, if we have, this is 5x plus 7x, will give us what? Will give us 12x. Will give us 12x equal to. Now, we'll have 52 plus 8 will give us what? 60. So, we are proceeding. Now, if we have 12x here, and we have equal to 60 here, now what do we need to do here now? What we need to do here is that we divide both sides by what? By the 12 here. By the coefficient of x, which is 12. Because the one x is carrying here now is 12 because we are looking for what? Only x. So in order for us to get only x, we divide both sides by what? By 12. So let's divide both sides by 12. Divide both sides by what? By 12. Now, if we divide both sides by 12 now, you can see that 12 now can cancel 12. We are left with what? Just x. Or even though you do 12 divided by 12, it's still 1. So 1 there and x is still the same thing. So just x, which is equal to, and then we divide this. Now let's divide 60 divided by what? 12. Now, in order for me to divide it, that will be very easy for me. I will just do what? I will just simply count 12 up to 60 and I will stop. So let's keep on adding 12 up to 60. We'll stop. Now 12 is giving us this 24. Then 12 is not to 60. This 36 is not to 60. 12. This 48 is not to 60. 12. This 60. So now it's up to. So now let's count how many of the 12 that is here. We have 1, 2, 3, 4, 5. So we notice that 60 divided by 12 will give us what? Just give us 5. So that is it.